Lydia's going to have a hard time understanding what that was. She might have to come in for an explanation. All right. So, each length of string here is called a radian. And we know that, I didn't finish answering this question. Using the pattern to see how many lengths of string would it take to get 180 degrees. So 360 would be the whole circle. That would be 2 pi. So what would 180 degrees? It'd just be 1 pi, just pi, right? So we know that 180 degrees equals pi radians. We also know that 360 equals 2 pi radians. But it is going to be, for what we're getting ready to do, it's going to be a little easier to use the 180 and the pi. Okay, so the first thing we're going to look at is converting degrees to radians. So this first one is our standard. It's like what we start with. 180 equals how many radians? Pi. Okay, so you got a couple options for thinking about some of these others. Okay, so if I've got a circle here, and I know that this right here is 180, which also equals pi. If I want to know 60 degrees, well, that's not really where 60 would be. Why is that not? Let me erase that. It's not quite where 60 would be. So, obviously, actually, let's skip down here. What about 90? Let's talk about 90 first. 90, right? 90 degrees right here. That would be half of the length to 180. So, it'd be 1/2 of pi, which can be written as pi divided by 2. So that's one way we could think about it, right? We could just kind of reason through it. But we're going to see some where reasoning through is not very easy. Yes. Yes. So if I have 90, if I cut that in half, that would be 45 degrees. So if this was pi over 2, then we could cut that in half. What would half of pi over 2 be? That would be pi over 4. Right? So 45 is here. That's pi over 4. Right? We could really reason through a lot of these. Because if I'm thinking like 60 degrees, let me use a different color here to draw that in. 60 degrees would be like right here. And let me add in 120. 120 would be right here. Okay? So if I'm thinking this whole distance all the way around right here is pi, if I split it at 60 and 120, right, that would be 3 equal increments. So what would 60 degrees be? It'd be pi over 3. So then what about 120? If this is pi over 3, and then you got another pi over 3 right here, so it would be 2 pi over 3. So we can do a lot of work just like reasoning between these, right? But some students are better at picturing what this is, like cutting these pieces in half and understanding what's happening. Some students are not as great at doing that. That visual part confuses you a little bit. Yeah, so what we're going to do, the way I generally teach this, because it's going to work both ways, is I teach to do proportions, which you're going to find shortcuts like that where it's basically going to do the same thing. But I teach proportions, and the reason I do proportions is because it works if you're going from radians to degrees or degrees to radians. Or you could have two separate rules for each one, so if you prefer like creating rules, you can come up with your own thing. So like for 60 degrees, just to think about what's happening, I know that pi equals 180 degrees, right? So pi over 180 would equal x over 60. So I got radians in the top of both of these fractions. I got degrees in the bottom of both of these fractions. Pi and 180 are equal to each other. X and 60 are equal to each other. I'm trying to figure out what this x right here would be. Right. So if I cross multiply here, you would have 180 times x equals 60 pi. And you're trying to find that x right there. So to do that, you would end up dividing by 180. And 60 over 180 reduces to 1/3. So you got 1/3 pi, which we can write. We're typically going to see that written as pi over 3 because that pi, it's like it's over 1, and you can multiply those. So that is another option. So like when we have 30 degrees here, now I did pi over 180 equals x over 60. I could set it up the same way. Let me remind you, proportions don't have like any specific way they have to be set up. I could do something like this. I could do 30 degrees over x equals 180 over pi, right? To check to make sure it's set up correctly, the top, both of those are degrees. The bottom, both of those are radians. 30 and x are equal to each other. 180 and pi are equal to each other. So you can set up that proportion. If you cross multiply, you get 180 x equals 30 pi. Divide by 180. Divide by 180. And 30 over 180 is going to reduce to 1/6 times your pi, which is going to just be pi over 6. There. Now, you don't have to use that proportion method necessarily, but there are going to be times where you're going to have to for ones like number 7 and 8. Because you can kind of reason, I mean, I guess you could reason through these, but it's going to become much more difficult to reason through here, particularly with that 50 degrees. And sometimes you might have decimals, like 51.8 degrees. And that's going to be really difficult to reason through. So for these, you can do, just like we've been doing with the proportion, 15 over x equals 180 over pi. And you can cross multiply. 180 x equals 15 pi. And divide by 180. And 15 over 180 reduces to 1/12. So you get pi over 12 there. Now, you'll notice whenever you're going from degrees to radians, the same thing's happening in these proportions each time. You cross multiply, you get 180x equals the other stuff, you divide by 180. So like you are doing 15 divided by 180 and slapping a pi with it, right? So you're welcome to shortcut that. The reason I like teaching proportions is because it's always going to work, and it's always going to work both ways, right? But you're welcome to shortcut it. Okay, I'm going to skip this one for right now. And I'm going to do one over here. Well, 2 pi, what's that going to be? 360. That's 360. And you could reason through this. Pi over 2, that one's going to be 90. Right? All right, 4 pi over 3, we hadn't really, let's use a proportion for that. Okay? You're right, I think it's 240. But let's use a proportion just so we can see how that sets up, particularly with that fraction. It can look a little weird, right? So we still know, it doesn't matter which one you put on top or bottom. We still know 180 and pi are equal to each other. Or we could do pi over 180. Doesn't matter. But if we put degrees on top here, we're going to put degrees on top over on the other side. We don't know degrees, so we're going to put an x. And on the bottom, we would do 4 pi over 3. So we would cross multiply here, and we'll get pi times x. So pi times x here. And then I will let you use your calculator on these, but I will, whenever you do this, keep the pi with your answer unless it's something like number 13, okay? Because if we do 180 times 4 pi over 3, well, this, I'm using the 89 calculator, you're going to get this big decimal. It will work. You can do it that way and then divide by pi, and it's going to give you 240. So it will work, but the easiest thing to do is do 180 times 4/3, which is going to give you 240, but there's still a pi there, so it's 240 pi, and then you just divide off that pi, and it's going to cancel, so x equals 240. You can, yeah. Your reasoning through it is perfectly fine, yes. Since you know pi over 3 is 60, that's 4 of those, so 60 times 4 gives you 240. Perfectly fine. I'm just trying to give you a lot of options on how to do it. Yeah. Now, when you get down here to 13, you don't have options. All right? Because we don't, 3.5 radians, you can't reason through that very well. All right, so proportion is going to be important on number 13. You've got 180 over pi is going to equal x over 3.5. Now, on this one, you would have to have a calculator. I could not give this one to you without a calculator. You would cross multiply. You would get pi times x equals, and then you do 180 times 3.5. And you would get 630. Then you have to divide by the pi. And so you would do 630 divided by pi. Hold on. I'm using my other calculator. I better hit that green button. And we get 200.535. So 200.535. There's no way you could do that one without a calculator. And you could like come up with shortcut rules. Like you're multiplying by 180 and dividing by pi is what you're doing. But it's still, even your shortcut rules are still essentially just doing that proportion there. All right. So try those other three that we didn't do real quick. And while you're doing that, I'm going to pass out our unit circles. You can throw it away here in a minute, but let's just wait until the end of the class to do that. You're welcome. Okay. All right. So, just real quick, for these, for number 8, you should get 5 pi over 18 radians. In general, if it will reduce to a fraction, you're probably going to see the fraction there. You also could do 5 times pi divided by 18 and get a number for that as well. You may occasionally see that. 12 is 45 degrees. 14, you should get 154.699. And you can always kind of like think about what you already know. We know that pi, which is 3.14, should equal 180. So if we got 2.7, that should be less than 180, all right? But not significantly less than 180. There. Okay, so, all right, let's look at our unit circle paper. And there are many, many, many tricks available for learning how to fill in the unit circle. I'm going to show you the way that I think about it and see if it is helpful to you. You must have the unit circle memorized. Now today we're just going to do angle and we're going to do the angle measures and the in degrees and radians. We're probably not going to get to filling in the other parts yet today. We'll probably finish that up tomorrow. Let me look at Canvas real quick. Let's see. That's calculus, so that's not going to help me. Let me see what day it was. Alright, so, no, still the wrong class. Good gracious. Okay. It's dragging today. Slow. Why is it doing this? Okay, so we're going to have a quiz on Wednesday, but on Wednesday you may still use your unit circle. So what we're going to write down today, you may still use that unit circle on Wednesday. But then we're going to have 2 back-to-back quizzes, but Thursday is going to be your unit circle quiz. Okay? Unless you've written on your paper, you're looking at your unit circle quiz. Okay? I made extra copies. They're sitting right here. I'm just going to hand you this blank unit circle and you're going to fill it out. This Thursday. Yeah.
He used to make us do it in less than like 5 minutes. He gave us like 5 minutes.
I generally don't time you, but it should not. I mean, 5 minutes is pretty reasonable. I am eventually going to call time, so if it's taking you 20 minutes, you're going to turn it in.
Even though like we all finished on time, it was still like
Yeah.
being time.
It was one of the things he gave you the paper.
I would try to make sure I could do it in under 5 minutes. You're probably not going to get much more than 5 minutes. Yeah. All right. So Thursday, you will have to know the unit circle. And after that point, so we are going to have a quiz Wednesday on using the unit circle. You guys will see tomorrow what that's going to look like and what you're going to do. There's a practice quiz that you'll do to practice for it. So it'll be no surprise. But on Wednesday, you may use your unit circle for that quiz. Thursday, I'm giving you the blank unit circle quiz, which should be a 100. It's memorization. Right? So you should get 100. But I always have some students that don't because they don't study it. All right. And then after that, no unit circle will be allowed on anything else we do. So I may give you a blank unit circle that you can use, but you will not be given the unit circle on anything else. So once I've given you that quiz. Okay? All right. So let's look at the unit circle. All right. Lots of ways you can look at filling this in. Okay? Lots of ways. But I'm going to try to help you the way that makes sense to me. That hopefully will also help you. Let's start with degrees because I think those are a little bit easier. Okay? So, this angle measure right here is 30 degrees. Okay? So this one right here is 30 degrees. And I should put here first, this is 0. degrees. And just like whenever we were doing vectors, those angles that I was giving you are like the unit circle. So 0 degrees is your positive x-axis, and you're going counterclockwise. Okay? So 30 degrees. Now, notice, I've got this length right here on the outside of the circle. If I travel that length again, it takes me right here. Right? It skips this piece right here because it's kind of halfway between. So what should this angle right here be? This one right here is going to be 60. Alright? Right there. Alright, so if I go that distance again, what should I get right there? 90. So I'm just adding 30 degrees as I go around, right? I'm skipping these these ones right here that make this little skinny pie piece. They're going to be half whenever we get there. So if I'm looking at just these, we'll highlight them here. I'm just going around and counting by 30 degrees. So this would be 120. This would be 150. This would be 180. This would be 210. 240. 270. 300. And 330. And then 0 degrees, it can also be 360. Right? If we go all the way around, we'd end up back at 0. And we're not going to mark it on the unit circle, but you could keep on going. You could have 390 and 410, like more than one rotation, but we won't do that for the unit circle. Okay, let's think about doing the same thing with our radians. We're going to come back and hit those other values, right? So, radians, there's lots of ways you can memorize it. Just tricks, you know, little songs, whatever, to memorize it, and that's fine. There's like a hand trick, there's all, whatever. Use whatever you want to use to memorize it. You don't have to think of it the way I'm showing you. But to me, this helps make sense of it, right? So, just like I just did, that's really simple to just count by 30s. 30, 60, 90, 120, 150, 180, right? So, 30 degrees is pi over 6. That you pretty much have to have memorized to do what I'm about to do. So, that means the next one, we're going to come back and reduce some of these. So, if you don't have a pencil, you may not want to do that. Hello? Yes. 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 You're welcome. Okay. All right. So if this is pi over 6, this is 2 pi over 6. We're going to come back and reduce in a minute. But it'll mess us up if we stop and reduce right now. So if it's 2 pi over 6, this would be 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And then 12 pi over 6. Okay? Now, these are not the numbers you have on the unit circle because nothing's reduced yet. But it's working the same way. We're just counting up by 30s, right? So, 1 pi over 6, 2 pi over 6, 3 pi over 6. You're just going up by pi over 6. So, if you remember those values on the unit circle, though, you don't remember having so many 6s. That is just because these will reduce. So, you could take 2 pi over 6. 2 over 6, what's it reduced to? 1/3. So, that's going to be pi over 3. 3 pi over 6. What's 3 over 6 reduced to? 1/2. So that's pi over 2. Then we would have 2 pi over 3. Two pi over 3. 5 6 is not reduced, so we leave it. Because some of these will be over 6s. 6 pi over 6. What's that reduced to? just pi. Which we really already knew that one anyway, right? We knew 180 was pi based on what we just did with all of our radian stuff. 7 pi over 6 does not reduce, so we leave it. 8 pi over 6. Oops, there went my highlight. That is 4 pi over 3. I'll put the highlight back there. Okay. 9 pi over 6 is going to be 3 pi over 2. 10 pi over 6, if we reduce 10 over 6, we get 5/3. So that's 5 pi over 3. And 11 pi over 6 will not reduce. 12 pi over 6, 2 pi. Are we okay here? We got degrees, we got radians, but we still have 4 that we have skipped, right? So let's think about, I'm going to get my highlight here. Let's think about this one right here. If this is 30 and this is 60, what's halfway between? 45. So that's 45 degrees. So I'm going to highlight here every increment of 45 degrees. Notice it's going to hit some of these we've already done. All right, if I go in increments of 45 here, it's going to hit some of these that I've already done. But with degrees, very simple. Just count around 45, 90. I've already got it written in. If I add 45 to that, I'll get 135. You could also think just what's halfway between 120 and 150. 135 plus 45 gives me 180. 180 plus 45 is going to give me 225. 225 plus 45 is going to give me 270. 270 plus 45 is going to give me 315. And then 315 plus 45 will give me 360. We okay with degrees? There. All right. What is 45 degrees in radians? It is pi over 4. So, with all of my little green highlighted increments, we're going to do the same thing we just did with the 30 degree angles, right? So, or pi over 6. So, I've got pi over 4. I'm skipping I'm skipping these that are like over 3 and over 6. I'm done with those, right? Then, so this is pi over 4. This would be 2 pi over 4 right here. Now, 2 pi over 4, what's it reduced to? Pi over 2. We've really already got that one figured out, right? But pi over 4, 2 pi over 4, that makes this 3 pi over 4. This is 4 pi over 4, but we've already got pi there. It reduces, right? This is 5 pi over 4. This is 6 pi over 4. That reduces to 3/2. We've already got that. And this is 7 pi over 4, and then you get back to 2 pi. There. Okay, questions? You need to be able to fill out radians and degrees on the unit circle for all of these. I'm going to pass out the notes for unit circle, and we're going to start. I don't know how far we'll get with these. That way you'll have them tomorrow, and we'll finish up tomorrow. Which was my plan anyway. So we're going to start the coordinates right now. We just probably won't get very far with it. Alright. Alright. Okay, and keep your unit circle out because we're going to fill it in sort of as we go through these notes. So, oh wait, that's the wrong thing. Alright, let's I think it's coming up. Okay. Alright. I actually need us to do. Okay. Let's look at our unit circle first. The unit circle is a circle with a radius of 1 that has its center at the origin. Okay, so if the radius is 1, let's flip over to our unit circle. There's going to be a few we can go ahead and fill in. So if the radius is 1, that means right here, this is the point 0, 0. That means the coordinates at this first point, the radius of this unit circle is 1. So that length that I go across the x-axis is 1, so that means my x-coordinate right here would be 1. My y-coordinate would be 0. Alright, so all of the angles that fall on the x or y axis I can figure out. What would be my coordinates for this top point right here? 0, 1, right? On the x-axis, you go over 0, then you go up 1 because the length of that radius is 1. Okay? What about over here at 180 degrees? -1, 0. And then for 270, 0, -1. So imagine the circle's not even there. You just got, these 4 points on the graph, right? Those are your coordinates of those points, is what you're looking at. So you got 1, 0 over here. You got 0, 1 up here. -1, 0 over here. 0, -1 down here. Y'all okay there? All right, so those are fairly straightforward to find. I probably need to teach you one extra thing, so just either on the back of your unit circle or on an extra spot on your notes. I'm going to add in a blank page right here. Let's do special right triangles. That's probably as far as we're going to get. Special right triangles. All right, you may or may not have done this because it is sort of like an optional thing to teach. Have you seen 45, 45, 90 triangles before? Have you learned rules for that? Okay, so if you have a 45, 45, 90 triangle, isosceles right triangle, yes. Isosceles means that two sides are the same. So if you have a 45, 45, 90 triangle, that would mean that these two sides right here, I don't know what they are, but I know they're equal to each other, right? Because the angles across from them are equal, so they have to be equal to each other. So, if you have a 45, 45, 90 triangle, the length of the hypotenuse is always the length of the side times the square root of 2. So you have seen it before. Others, have you seen that before? This means if I have this triangle, and this side is 3, and they tell me that these two angles are equal to each other, if I'm finding the other parts, this side would be 3. What would the hypotenuse be? 3 square root of 2. All right. These are just shortcut rules. Some teachers don't teach it if they're short on time because you could do it with trig, right? You don't have to know the shortcut rules, but they're going to help us on unit circle stuff. Also, what if I have this triangle, and I know it's a 45, 45, 90, and they tell me that this side right here is 6. What would the length of this side right here be? I wouldn't multiply them by root of 2. I'm going backwards. I would divide by square root of 2. I'd have 6 divided by square root of 2. Which if you rationalize, I think is 3 root 2. But so 45, 45, 90, your side length times square root of 2 gives you your hypotenuse. Okay. The other ones that we learned are 30, 60, 90. And in a 30, 60, 90, oh, I've got that backwards. That should be the 60. It's the bigger angle. In a 30, 60, 90, the side you really want to know is the short leg. If you know the short leg, then the hypotenuse is twice the short leg. And the longer leg is going to be the short leg times the square root of 3. And we are kind of out of time to continue with that. So we will finish up these notes and work on actually using the unit circle tomorrow.